Well, this is practice number 2. It is called microstructural changes during arc welding. The main purpose of this practice is to know better how arc welding affects the microstructural composition in our steel. And so we are going to analyze the the grain sizes and its proper mechanical properties. Well, the material needed in this practice are steel plates, alumina, um, electrodes for welding, uh, carbide, silicon carbide, and phenolic resin that is better known as bakelite. Well, the first step in this practice is choose two two plates of steel and weld both. This in order to achieve one of the purpose of this practice. Um, the weld has to be uniform in order to get them together. And then we have to cut them in the part of the weld in order to have one part with the welding and then encapsulate this with bakelite. Otherwise, we have to cut a piece of steel, but without welding, and we're going to encapsulate it. Well, once that we have our both pieces encapsulated, so we are going to put them in a machine that works with silicon carbide, and that machine is going to make them to have a mirror-like finish like this, so they have to reflect the light and look like it is shining. And this in order to go next to Baker's machine and know test them and know the hardness of each one from this welded part and this that is pure steel. Well, once that we are in the Baker's machine test, um, we have to make three three tests in the non-welded piece that of steel, and at least 10, 10 tests in the welded one. This in order to get more data about it hardness, and also to make better the approach of the changes between their hard. Well, as we can see in the next pictures, um, the unwelded steel has a approximate um, a, a hardness between 149 and 153. Then, once that we make the bigger test for welded steel, we can see that the hardness of this one goes through 164 and 172 as the toughest. Well, once that we test these two pieces, um, we're going to continue to give them a chemical attack with nital, that it is a substance that help us to attack steel, and this is in order to go to the microscope and see the grains each of each piece. Well, once that we have our pieces attacked, we're going to test them. Well, to see them in the microscope, so we can see their grain sizes and compare them. This one is in order to know better how the mechanical properties changes between welded and unwelded steel. Well, as we can see, we have to calculate the ASTM grain size. So in the the formula is n equal to 2 to the n minus 1. Um, the height n is the ASTM grain size, and the little n is the number of grains that we see in the image of the test in the microscope. So for the welded steel, we can compute that it is a 5 ASTM grain size, and then for the non-welded steel is 4 ASTM grain size. This means that the welded one is its grains are in well, the bigger the number in the grain size, the little is the grain in the real life. Um, so with this we can assume that the the welded steel more got harder than the unwelded, but it is brittle and less ductile than the not welded steel, because the matrix is the one that affects directly these mechanical properties. Well, the arc welding with a coated electrode works with an electrical resistance that provides the electrode heat. This in order to get melted and put together the plates. So the coat provides gases in order to prevent the weld contamination. Well, my conclusion of this practice is that welding is a cheap process and faster than others, and with this we can change the mechanical properties of the material that we are welding. Um, this one affects the mechanical properties in order to make sometimes the material harder, but it changes its brittleness and